Good morning, class 8th. Welcome to your physics class. So, the first chapter we are going to take is chapter 1, matter. You've already studied about matter in your previous classes, like the definition of matter, the three states of matter you already know: solid, liquid, and gas, their properties, and also you have studied how matter converts from one state to another, right? So, in this chapter, we are going to study kinetic theory of matter and how different properties of matter can be explained on the basis of kinetic theory, right? So, let's begin with the kinetic theory of matter. So, in this theory, I hope the visual is clear to you all. So, in this theory, there are two assumptions. These are two what you call uh, things which are supposed in this theory. So, what are those 2 points? Matter is made up of small particles. Okay, every matter is made up of small particles, and this is what these particles are what we call atoms or molecules, right? Then the second point is all these particles, either it may be atom or molecule, so these particles are constantly in motion, right? So you already know anything which is in motion has kinetic energy. You must be knowing this. You have studied kinetic energy and potential energy, these terms in I think 7th class. So anything which is having motion, there we use the term kinetic. So that body will be having kinetic energy. Now we are saying that each particle of matter is having constant motion. That means every particle is having kinetic energy. And due to this, because each particle of matter is having kinetic energy, that means the whole matter, the particular material that we're talking about, that is having kinetic energy. So every matter has kinetic energy, right? Now energy is related to temperature, right? So whenever a material is heated, a substance is heated, what happens? Its atoms or molecules or its particles start vibrating or start moving with a very fast speed, right? So when the speed increases, that means its kinetic energy will increase, and when kinetic energy will increase, that means the energy of the matter itself will increase, and this increase is energy is shown by rise in temperature. So whenever we heat a material, we heat a substance, its kinetic energy increases, and that is why its temperature increases, right? So you need to uh, remember these 2 points, these 2 assumptions of kinetic theory of matter, and these are some consequences on the basis of which we can understand matter with the help of kinetic theory, right? So next thing is the 3 states of matter. So you already know what are the 3 states of matter: solid, liquid, and gas. Okay, so matter, you have already studied that there are different things on the basis of which different states of matter can be differentiated from each other, right? For example, you have studied that in case of solids, the particles are highly packed together, and the attractive force is more, intermolecular space is very less, right? So these are the things we have already studied in earlier classes, and still for your revision purpose I have written the definitions over here. The attractive force between the particles of matter is called intermolecular force, right? You must be remembering this. And the space between the particles is called intermolecular space. Okay, so coming to the solid state, what happens is the particles in case of solid are very closely packed together, okay, and also in an orderly manner, right? So mostly the way particles or the atoms are arranged in a solid is a pattern, a manner in which it will be arranged. And you can say that if you have a material, suppose we take an element, suppose I take sodium. Then the atoms which will be arranged in sodium, any sample of sodium will be giving the similar arrangement, right? So atoms are arranged in an orderly manner and they are very closely packed. What does that mean? That suppose if I have this container, right? Or you say that I have this a piece of solid, then the atoms are closely packed. That means they are not going to leave any space between the particles, right? So they are very closely packed together, right? They are very closely packed together. Then intermolecular force is very strong, okay? So that means two consecutive atoms will be closely packed with the help of the intermolecular force between them, and that is very strong, right? Then the next thing, solids have least energy. Their energy is very less. We'll be coming back to this point, okay? Then they have definite shape and size. This also you have studied earlier, that solids have definite shape and size. If I have a suppose here I have a pencil box kept over here, right? So it will be having a definite shape and size. It's not that it is cuboidal right now and after some time when I come back it becomes something else. No, it will have a definite shape and size, okay? Then they are rigid. Solids are rigid, okay? What is rigidity? Let's come to that point. The property of a material due to which it retains its shape. What is retaining? What does this word retain means? That it keeps its shape intact, okay? It is not going to change its shape even when it is subjected to great force, okay? So when we apply some force on a solid, let's come back to this box again. So when I'm applying force on it, it is not going to change its shape very easily, okay? So solids are rigid. Its shape will not change easily, and so this property is called rigidity, and the material which is having this property of rigidity will be called rigid, right? So this property is very useful in the construction of bridges, buildings, and etc., right? So when we are making bridges or something, so we need it to stay strong. We need it to not change its shape or not break easily even when so much of force is applied. You know, the bridges, they are bearing so much of load on them, no? The traffic, all the traffic is moving over them, maybe some train is moving over them. So that thing, this bridge should have a very high rigidity, okay? So this property rigidity is useful for the construction of bridges, buildings, and so on. So okay, so children, you need to recall the properties of solids, liquid, and gas, right? So and just go through what I have shown you today. I'll be sending the image also if you want, these notes which I have written, and I'm leaving you with these two questions over here. See, why do solids have least energy? I just told you here, this there was one property, solids have least energy, okay? Why did I say that? You just think over it, okay? And we'll be coming back to this point again. So why do solids have least energy, and what happens when solids are heated? I already told you in the topic where I was telling you the kinetic theory. I already told you here that when materials are heated, the energy increase due to which its temperature rises, right? So this point will help you in answering both of these questions. So just think over it. How does solid is having least energy, and what will happen when a solid is heated? So think over these two questions. I'll be coming back to you to these questions when I'll take the next lecture, right? So by that time you can start writing the important points which you got here, Well, I have already consolidated the whole portion which is given in your book, right? So you can just write it down somewhere and try writing the answers of these two questions. Okay, so that's all for today. Bye, stay safe.